So this symbol means summation, sigma, and it's going to allow us to add very quickly. So I start here at 1, and I do 2 and 3 and 4. Now, am I going to go all the way to 5? No, because this says go from 1 to 4. So this is where you start. This is where you stop. It's that easy. So you're going to plug each number in. So what is 4 plus 1? Oh, sorry, 4 times 1. Let's write down what's going on. I won't make you write this 100 times, but the first time in your notes, you should write the whole procedure. So later you're like, what did I just do? And this is going to be 4 times 2 plus 1, 4 times 3 plus 1, 4 times 4 plus 1. Just anywhere you have a variable, you're going to plug the numbers in. You'll start with the bottom and work your way to the top. Now I want you to notice something. Remember, I told you this unit's all about patterns. And one of the goals I would like you to set for yourself is not just in this unit, but anything you're doing in math, always put the question in the back of your mind, do I see a pattern here? Do you see a pattern with these numbers? And make sure that you've got your mask up. I see people with masks off. What do you notice about these numbers? For what? Yes. But what's the difference here between 5 and 9? Yes. And what's the slope? 4. So I want you to notice that, and this is something that you probably haven't thought about before. You probably don't just naturally think about it. But whenever something's linear, okay, if it's 4x plus 5, anytime you have a number times a letter plus a number, mx plus b, the difference in your sequence is always going to be the slope. Because when you think about it, that's like 4 over 1. So it's up 4 over 1, up 4 over 1. I'd like you, when we look at these, we can clearly see that those are not linear. But whenever you see linear, if you can figure out the pattern that if you know one number, all you have to do is keep adding the slope, you can speed up. It can make things click faster. And that's, not so important in our class because we're not short on time, but when you're taking a major test like SATs, ACTs, college entrance exams, that may be of use. Once you find all these numbers, that symbol means to sum. So we're going to add them up. Now you add up your answers. What is that, 44? Yes. So that's the answer. Now, what if I told you to go from 1 to 1,000? How excited would you be? Not really. So if you will get your calculator, you're going to love this. You can go alpha, window, 2, and looky there. You can use the letter X. You don't have to put an I in there, whatever letter, it doesn't matter. X equals 1. And then you just arrow, you put in the 4, and you say 4x plus 1. And then you say enter, and it spits out a 44. Right? I'm gonna see. If you've got an older calculator and you don't have the sum button, you can go to math. Let me find it. Summation, which is number 10, and it pulls it up. So did everyone find that on your particular calculator? Math 10. So you either go to Math 10, or if you've got the alpha button, if you've got a newer LCD screen, I recommend getting used to your alpha key. If you've got an older calculator, you could do the Math 10, okay? but it's going to add things up for you. This is simply arithmetic, and that's not something we want to worry too much about. So why don't y'all go ahead and punch these other ones in and let me know how it's going. Oh, actually do B, because C has a symbol you don't know. So y'all punch B in. See if you got it. Did everybody get it? 232? Anyone have a problem getting 232 going in your calculator? Use your alpha window 2. Okay, now this guy has something different. And let me explain what that is. We're going to go down here. The notes are a little goofy, I think. Let's do these, then we'll come back and do this one so you understand what that is, okay? Everybody got 232, right? You're okay finding the buttons in your calculator? All right. So this is called a factorial, this little exclamation point, and what it means is you multiply by every number before the one you're at. So here's 4. So that means 4 times 3 times 2 times 1. Okay, 4 times 3 is 12, times 2 is 24, right? Not hard. Now you can go into your calculator, right? Now let's make a list of how you get there. Alpha, window, 9. So alpha. Do this by hand. Now do it in your calculator. Make sure you can find it. Or math, PRB or OB, whichever calculator you have, 4. So everybody go into your calculator, depending on the style or the year or the model you have, and find the factorial button. It's either under alpha window 9 or math probability 4. Okay, if you have under math, if you have a new calculator, it's PROB. If you have an older calculator, it's just PRB. Doesn't matter which one you have, you just have to learn your notation, and you go over there, and number 4 is the factorial button. Did everyone find the factorial button in your style of calculator? Okay. So did everyone get 24 with a calculator? Now I want to show you that these are actually very easy. And if you take a test without a calculator, it's very easy to do them by hand. So let's do a couple. I really want you to do them with me. I can actually do these faster by hand when you have a big one like this, then I can type them in. This would take me a while to type in, but let's look at what it really means. And it's actually very simple. This is 3 factorial. I'm going to write it down like that. Actually, yeah. And then I notice in the bottom, I have a 4 and a 4 and then an 8. So just watch what I'm doing. So you'll know how to do this without a calculator with no stress. 8, could I call 8 times 7 times 6 times 5 times 4 factorial? Could I stop it? Yeah, I could. And then I could say that this is 4 times 3 factorial. And I could just call that 4 factorial, right? Do you see what I did? I matched them up so that I got a 3 factorial and a 3 factorial and a 4 factorial and a 4 factorial. And now I could say 4. Well, I could say this is, and there I've got 5 times 2 is 10 times 42 is 420. So if you see what we did, and we're going to practice on this one, I want you to go ahead and type them in. but I want you to start the clock. We're going to do this one together. And I want you to see how long it takes us. Then I want you to type it in and see how long that takes, okay? So if I had 9 factorial, y'all just watch me for a second, okay? You watch me and time me, and then you do it by hand, and then you do it in your calculator to watch. So ready, go. That's 9 times 8 times 7 factorial, and that's 3, so that's 3 times 2 times 1 times 7 factorial, so the answer is 12. How long did that take? Okay, now type it into your calculator. You need to use alpha 1 to get a fraction, and you need to go to alpha window 9 or math PRB to get your factorial. Time how long it takes to type this in. And I don't care that you use a calculator, but I want you to see these are really fast. See what I mean? It's worse to type it in, isn't it? Make sure, everyone, I want to see fingers going. Make sure you can use your calculator. Remember, if you don't have one, there's one to download for free on the internet. And you have a calculator. I just want you to see how easily those cancel out. And I'll be happy to redo this one if you're like, wait, you're magic, Coughlin. How'd you do that? Everyone get them? I'm going to pause this for a second in case people are watching so they can stop. All right, so now I want you to go back and try this one because we needed the factorial button, and now you know how to find that. So you're going to go to Math 10 or Alpha Window 2, get your summation. We start at 1, end at 6, and then you've got your alpha y equals, right, for a fraction. We'll get your fraction, and you know how to find the factorial. So this is just, can you go in there and put it all together? If you use your fraction button, you should get a fraction. So this is kind of just a math check. So everybody go in, work with your calculator and try that. Okay. So when we look at these, we find A1, AN, N, and D, and we simply plug it into this formula. First term, last term, how many there are. Here, we noticed it was easy to figure out what went in between, so we could count 1, 2, 3, 4, 5, 6, 7. These are just going in order 1 to 35, so there's 35 numbers. First number, this is A1, this is AN, there's 35, the difference is 1, and we just plug them in. Any trouble using that formula? No? Okay. Now what about this one? Tell me what's different about this one. Find the 50th partial sum of -6, -2, 2, 6. What does ... mean? Means it goes on forever. So it's infinite. So let's look at this, right? What do I need to know? Well, I need to know N. I need to know A1. I need to know D. And I need to know N, AN. I need those 4 things to do it, right? Now let me ask you this. It says partial sum of this goes on forever. If I'm going to add numbers, this is arithmetic. Remember, we're specifically talking about arithmetic. We'll get to geometric in a minute. If a list of numbers goes on forever, can I add them up? I can't add them up. They don't stop. I can't. What am I going to do? That's why here we see that it's a partial sum of the first 50 numbers. So if I had a list that went on forever, I could say, hey, can you add up the first 10? Can you add up the first 250? I could give you part of a list to add up. And that's what this means when you see partial sum. We're going to add part of them. So N is 50 in this case. A1 is easy. That's -6. Now, can you figure out the difference between them all? What's it going up by? 4, 4, 4. So D is 4. Now, how do I find AN? I go back to yesterday. Go back in time to yesterday. Oh, I should play the Beatles yesterday, or John Lennon yesterday. What's the formula you had from yesterday? Yes, as a matter of fact, hold on one second. Okay, so we have this formula from yesterday. So how are we going to use that? Well, sometimes you have to use yesterday's formula to find missing pieces. AN equals A1, which we know it's -6 plus N minus 1 times D. What is N minus 1? They said the 50th partial sum. So how many numbers are there? 50. So N minus 1 is 49. So what is AN? Punch that in. 49 times 4. That's actually like 200 minus 4, which is 196 minus 6. Is it 190? I did that in my head real fast. Do y'all know how to do 49 times 4 fast in your head? Just do 50 times 4. That's one more, and know that you added one more on 4 times. So I do 50 times 4 is 200 minus 4 is 196. You can always do things fast in your head by going up to the, 10, 20, whatever. 190, so now I know that. Now that we have AN, can we use this formula? over 2 times A1 plus AN, right? The nice thing is none of these are stressful. You have your formulas, you have this, put this on one sheet, and then tonight what you should do, or when we're done taking notes, put all of your calculator functions on there. The alpha math this, alpha math that, right? Are you okay with that? Now, what about this guy? You can just punch it into your calculator, right? But let's try it with this. I want you to try this, right? I can figure out A1. What is A1? Plug 1 in. What is A1? 3. What is AN? Plug 25 in. What's 25 times 4? Minus 1. What is N? How do you figure out N? I want to make sure you can figure that out. Yeah, but what if I was going from 7 to 25? How could you quickly figure that out? It's top minus bottom, right? Plus 1. Since we're going from 1 to 25, if you just subtract them, you've gotten rid of your first number. So 25 minus 1 is 24, plus 1 is 25. It's easy when it starts at 1. You automatically say, oh, 1 to 30 is 30. 1 to 25 is 25. All right. So you can use this formula for that one, right? Or you could just go with what I showed you and type that in. So y'all do that one. Use this formula. Also go and plug it into your calculator like we just practiced, right? Everybody type that in. Make sure you can do it. At this point, we are just at calculator functions, aren't we? We're not really doing any math. We're typing it into the calculator. Everybody get that? Anybody need help? Pauses. Okay, so again, on this one, A1, you plug 1 in. AN, you plug the top number in. Okay, and we've made a list of all of our calculator functions. Everything we do in this unit, let's make a list. Then you have one thing to look at when you're taking a test or studying. Okay? Is everybody okay with these? Good news and bad news. The good news, we have more stuff to do and you're not done because you're excited. Bad news, we got more stuff to do and we're not done because you're excited. We added up arithmetic sequences. So now we need to know how to add up a geometric sequence. It's the same idea, just a different formula. Okay, so for me as a student, I have my geometric colored pink. So if I'm geometric, I know to look at those. I have my arithmetic turquoise. And of course, I can write these on a piece of paper. I don't have to have a printout. And on my calculator functions, I'm feeling good. I'm going to nail this test. I want a 100. Okay, so here we can see we need R. R is just that common ratio. We need N. N is how many things do you have? And we need the first one. Which one don't we need in a geometric? We don't need the last one, do we? Okay, so let's look at this guy. This is, I'm telling you, these are geometric. If you didn't know, you'd have to figure it out. And please put commas. These should really have commas. So how do I get from 1 to -3? And then -3 to +9 and +9 to -27. What is my R? -3, right? Because 1 times -3 is -3. -3 times -3 is +9. +9 times -3 is -27. Do we know the first term? 1. Do we know the last term? Yes. Do we know how many terms there are? No. Uh-oh. How do I figure that out? Well, this looks pretty short. So I have a choice here. I can go back to yesterday and I can use logarithms and I can get the exponent down and I can figure this out. Or how long would it take me to get to 2187 multiplying by 3? What's 27 by 3? What's 81 times -3? 243? And what's 243 times 3? What's 729 times 3? Oh, yeah. So there's 1, 2, 3, 4, 5, 6, 7, 8. I will do this with you if you want me to in a minute. If it was really long, you're not going to get any of those right now, but I'd like to do it with you just for those of you who are excited about math. But let's do it kind of the easy way. Then I'll go back and show you that. So I have everything I need. So I say N. So Sn equals what? A1 times 1 minus R to the N all over 1 minus. Now, if I were doing this rather than typing 1 minus -3 into my calculator, I would just put a 4 on the bottom. I would rather simplify it, but this is just a matter of punching that into your calculator. So everybody punch it in and make sure that you can get 1640, right? So we're going to say, let's do this together. Do I have to do 1 times? Do I have to type in the 1? No, we're multiplying by 1, right? So it's what? Alpha y equals 1. And make sure your mask is on. Right? That's all you have to type in. -1640. Oh, is it negative or positive? That's negative, isn't it? So that's a big positive number, 1 minus a big positive number. Okay. Is that okay? Are you good? Is everyone good with your calculator? Okay. All right. How are you going to do this one? Do we need to go through this process or can we punch it in? Let's do both ways. Let's make sure you're adept at that. Okay. You could face a problem like this without a calculator. They could give you easy numbers to work with. So let's figure this out. We need to know A1. We need to know R and we need to know N. That's all we need for these, right? Those are your three variables. So what is A1? You're going to plug 1 in, right? So that's 2 to the 1 minus 1 equals 2 to the 0. And what is 2 to the 0? 2 to the 0? 1. R. What is R in this case? That's your R. It's whatever's raised to a power, right? So what is R? 2. And what is N? N is 7 minus 1 plus 1, which equals what? 7. Now, why am I being silly enough to write minus 1 plus 1? Because this might not be a 1, right? So let's say this 1 is that 1. And this 7 is this. And let's make a note to ourselves in our notes so we don't ever forget this. Always add 1. I don't want you to think that this 1 is because that says 1. We always have to add 1 because when you subtract numbers, you're finding the difference between them and you got to add the first number back in. Okay. All right. Calculator people, let's see what you can do. What do you get? Let's do this. Right? So do it this way and then do it the way we just learned by putting in the summation into your calculator. Make sure you can do it both ways. Okay, I'm going to give you a minute. Okay, so now I'm going to have you try this one, whichever way you like it, either by alpha window 2 calling up your summation or by using this formula. You're really good either way, right? So go in, put that in and tell me what the answer is. I'll tell you what I got. I'll type that in. Now, on this one, what is N? I want to do the N part. How many numbers are there? Well, it's 20 minus 0 plus 1. Remember, we always add 1. So how many numbers are there? 21. It's okay if you don't do this by hand, but I wanted you to see how the N works out. Everybody have that? Are we good? Oh. All right, there's something really crazy going on here. It's unbelievable. Look at this. Sum of an infinite geometric sequence. So we just talked about the fact that if I gave you a list of numbers that went on forever, you couldn't possibly add them up. Arithmetic one, we can't. But I'm here to tell you, I can give you an infinite list of numbers in certain conditions of a geometric sequence, and you can add them up. How is that possible? How is that even possible? Well, let's look. I'm going to go to the back page and we're just going to think for a second. Tell me what 1/2 times 1/2 is? 1/4. Now I want you to multiply times 1/2 again. What is that? 1/8. Now I want you to multiply by 1/2 again. 1/16. Now let's multiply by a half again. 132 times a half. Okay, I got to keep going. I want you to see why this works. What's 1/64 times a half? Times a half? Times a half? Let's do one more. What's 1 over 512 times a half? Do me a favor and plug 1 over 1024 into your calculator. What does that equal? What was it?
9.76.
-4. So that's essentially 1, 2, 3, 4, right? 0.000976. What happens if I multiply that by a half several more times? What is this number approaching? 0. So in the condition where your R is less than 1, meaning it's a fraction between -1 and 1, like the top is smaller than the bottom, 1/2, 3, 4, 7/8. If you keep multiplying by a fraction, you essentially get to 0, right? So it is possible to add up an infinite series if it's a geometric sequence and R is a fraction smaller than 1, top is smaller than the bottom. Does that make sense why that would happen? Because if you did several, eventually you saw that we didn't have to go too far, and then we're just adding 0 on. So you can get there. It's kind of cool. Actually, it's very cool, right? So all I want you to do is, first of all, ask yourself, is it possible? R must be between 1 and -1, right? That is R. So is it possible to add these up? Yes. This is 0.1, that's R. Is it possible to add these up? Yes. I'm going to come back and do it in a second. That's R. Is this one possible? No. You would not be able to do that one because 3, if you keep multiplying by 3, 3 to a power, 3 to a power, 3 to a power, it's just going to get bigger and bigger. You can't. But when R is small, we can do it. And it's a very easy formula. Now you can type this into your calculator, right? To get infinity, you type 99e. You better add this to your formula sheet. And if you think it wasn't hard for me to figure that one out. But let's just try this. What's A1? You really don't need the calculator. What's A1? Well, what's 1/2? A1 is 0, right? You plug 0 in first to get A1. What's 1/2 to the 0? Times 5. 5. A1 is 5. What is R? R is 1/2. So all we have to do is say 5 over 1 minus 1/2, which is 5 over 1/2. What's 5 divided by a half? Well, 5 divided by 1/2 is 5 times 2, which is 10. So this is very easy to do by hand. You don't have to, but take a minute and plug those into your calculator and make sure you can get the answer. Remember, you get your calculator for this one. Okay, so if you type that in, you get the decimal. You can go math 1, and it will turn it to a fraction for you. If you hit your math button, you can convert to fractions or you can convert to decimals. Right? Everybody okay with these two? Do you need more time to work on them? All right. Then, of course, we determined that this one was not possible because 3 is bigger than 1. Okay? The last thing is write the first 5 terms of the sequence. So what do we do with that? We want to write the first 5 terms. You could do it by hand by plugging 0 in, or you can just do it in your calculator, right? Let's do it in the calculator. What do we want to do first to set this up in our calculator? We want to use what button? Alpha y equals 1. So we want a fraction. Type in what you see. Of course, you may use the letter x. And this is x. How do I get that factorial? Right? And I hit enter. Why did I do that? What did I goof up on this? If I want to write the first 5 terms really fast, this is what I meant to tell you. Where do I type this? Right there. Sorry. Alpha y equals 1. So 3. I got all sad thinking about the fact that I only have one more day to go over notes with you, and then we're pretty much done. Oh, shoot. Did I type that in right? It looks funny. My X looks funny, but it's because it's hooked on there. So we can do that now. If you want the first 5 terms, where do you go to get those? Second table. And you have the first 5 terms, right? I wanted to point that out. Sometimes we're not used to being able to go to a table and y'all will just type them all in. We don't have to do that. Y'all know if you ever have to type 5 terms, you got to do something. We go to y equals and then second table. Right? The second table will give you any x that you want or any n, whatever letter. If I wanted to know the 15th one, I could just scroll down to 15, right? Okay? Are we good? That's it.